Okay, yeah, we'll get started. So we've plenty of people registered to attend today, and thank you so much to those who have joined us. So this is our third event in our series, Emerging Trends in Digital Engineering. And we are focusing on AI today, which has been a very hot topic this year and spoken about in the media, etc. However, here in Engineers Ireland, we just want to have a focus on the benefits of AI, and with Dr. Kevin Koidl and Ali Parandeh today, just looking at some of the limits within AI and also an ethical approach to it, or the ethics within it, and just to make AI less of a scary topic to approach. So joined with us today, we have Dr. Kevin Koidl, who has spoke with us previously about ChatGPT. Kevin is currently a visiting professor of technology and innovation in a college in the US called Emory and Henry College. Kevin was also a research fellow, or is a research fellow in Trinity College in the ADAPT Centre. He has a huge background in academia with a dual master's in both business studies and computer science, and also has a degree in philosophy specializing in ethics and AI. And then we also have Ali Parandeh. So Ali is a co-founder of a company called Build Your AI. So it's a UK-based educational platform which is educating in AI. Ali's also a chartered software engineer, and also founded a beginners learning machine group, supported by Microsoft, which is helping professionals break into data science and AI. And Ali has over 7 years experience in the field, working with companies like the Department of Transport, London Transport, and on projects such as HS2 and the Heathrow Express. So yeah, plenty of knowledge and experience there in the field of AI. Both of our speakers today will be discussing large language models, with obviously a different angle or a different approach from both of our speakers. So we'll look also at the AI timeline, where we started and where we're at now. Also looking at or specializing in imagery from Ali's approach, and on Kevin's side we'll look at evaluation methods and the bias model, and also environmental impacts with AI. So that's a lot to take in there. So first of all, I just wanted to say the event will be recorded, so I will send that out shortly following the event today. Just to note as well, we will be leaving plenty of time at the end for a Q&A. Please feel free to pop the questions into the Q&A function on Zoom as we move along. We will need to end the webinar abruptly for 2 p.m. As our speakers have places to be. But just to know, if you have any questions specifically for either, just to add them in as we go along. And other than that, I hope you enjoy, and I'm going to pass you over to Kevin here now.
So thank you very much, Annie, for the beautiful introduction. It's always interesting to hear someone else introduce oneself. It's like, no, that's not me. So I'm very happy to be here. I'm very happy to be asked to talk again here for Engineers Ireland. We did a similar talk I think it's about 6 months ago now. So maybe there's a couple of you in the audience attending that have been listening to similar stuff already last time. This time I want to extend on what we've been talking about, and I want to extend on specifically limits, because we've been, as a society, confronted, I wouldn't say confronted, but maybe some of us feel confronted with AI specific technology that suddenly came out of, for some of us, looking like coming out of nowhere and challenging us with very stark societal questions, such as, will AI take our jobs? And then there's a lot of scaring about that. Will AI take over the artists? Will we have issues with copyrights? Will we never again talk with a human on a phone? If we ring a company, will it be all chatbots and all machines and all this kind of stuff? These developments that happened in the last, I would say, 12 months, all around large models in two fields specifically. There's three fields in AI. And at the moment, you just see my title slide. I'm just going to talk over that for a few minutes. And there's three core fields in AI, which is speech-based AI, language-based AI, and image-based AI. And the two big ones, and the two speakers today representing these two fields, are language-based AI, which I will talk about, which we know as large language models, or most prominently used or became famous through ChatGPT. And then there's a second field which relates to image AI, and image-based AI also verges into vision or into video-based AI. So usually a video just being a sequence of images. And here the topics of deep fake are interesting, where obviously we as society are very worried if we see a video of a politician or maybe of someone important in society, can we actually trust that that person is really the person that is speaking? So what are the validation mechanisms behind that make us know or validate that this is a real person or not? And that brings us to the third one, which is speech-based AI. And that's kind of just launching at the moment, but you will see apps coming up in the next few months where you speak into the app as your voice. You will say, hello, my name is, in my case, I would say, hello, my name is Kevin, and I'm giving a talk today about limits of generative AI. And then I could just switch this over and have the voice of Leo Varadkar say that, or the voice of even Neve or Ali, if there's enough data to train the data set. So suddenly we're looking at a society or potential ethical implications around, okay, if we can't believe the image, if we can't, so basically the view of it, if we can't believe what is said and we can't believe how it is said, do we have a complete reconstruction of a potential sci-fi novel or something like that? I am here specifically to debunk that a little bit. I'm not too worried about these scenarios, specifically because we're aware of them. I think the limitations also on the ethical side are a little bit in other spaces, in more down-to-earth spaces, which are very much technical limitation, environmental limitations, energy limitations, these more boring topics that will hold up or create hard limits for these AI-specific technologies. So I'm not here to spread a doomsday scenario, and I hope you are not too much. Hopefully not getting sleepless nights over this and imagining Terminator walking into your garden at some point in the near future. I would call myself a positive technologist, but curious, because obviously the dangers of AI, I see a lot more in the military space, a lot more in these spaces where AI becomes, and that's the big term, weaponized for the interests of specific groups or nations. But I won't be talking about that too much, because obviously that would be a bigger, deeper political topic that is interesting, but still very, very complex and very hard to unravel. So what I want to talk about now for a few minutes is just to kind of motivate these limitations. So I'm going to give you a little bit of an overview of these limitations and go a little bit deeper in some of them, but not too deep, because we have very limited time. I'm more conscious of the Q&A, and I'm more interested in hearing what your questions and concerns are. And if we don't have time to answer all of those, maybe you can just put them in the chat and we can come back to them and maybe email you about them. And these kind of things are all possible. So let's look at these generative AI models and the limits of these. And specifically, the big one that we all are aware of is ChatGPT, and this GPT thing, this transformer model, or where this kind of thing comes from. And we all, I'm assuming most of you have been somehow confronted or have used ChatGPT, and this is the ChatGPT interface where I just asked it, what is a large language model? Like, what is this large language model and what is this thing, GPT. And in this case, it's the version 3.5. Version 4 is kind of there. You have to pay for it and so forth. But what does that even mean that it has different versions? And a large language model, basically, this interface gives me an answer. So it constructs this answer. I'm just giving you a quick synopsis of what this is in case you haven't been touched with this. So once I ask this interface a question, this interface analyzes the question and analyzes this question based on certain linguistic structures. So this is a what is question. So that's already kind of a giveaway in terms of a linguistic pattern where we know, okay, what is a question that tries to elude a concept or a topic or an entity, something that is followed by, okay, here's a qualifier where it says large language model. So, okay, now we could look up Wikipedia, for instance. This is a typical Google query where Google as an index would basically just use these keywords and would throw them into an indexer, which then creates a keyword matching and brings you a result list. And Google does that pretty well. Within milliseconds, it gives you 5 billion results or something like that if you ever looked at the result list in Google. And then you have the first page, second page, and so forth. But the big difference between Google and ChatGPT is that the text that Google retrieves is all a reference structure to text that exists. So it's, so to say, historical data, if we want to talk as a data scientist. So you're using historical data that exists, and Google's job is to quantify and qualify which one of those links that Google finds and puts into the first page, second page, and so forth, basically into a ranked list. And Google has to qualify which ones are the most trustworthy pages. So how much can Google trust that these pages are not fake or give answers that are kind of crappy? And Google has metrics around quality of the page, quality of the language. Is it responsive? Does it kind of fit the size of the screens and so forth? But ChatGPT is different. It generates a result. So this result that you see, a large language model, is a type of artificial intelligence systems that are trained on vast amount of data and so forth, is a new. If I put this same query, we call it in this instance, we call it prompt. If we prompt the model, which is a static kind of a statistical model that has been created and trained to be queried, if we prompt this model with this query, I will get a different result every time. The result will be linguistically similar, so because the topic is very specific, and it will most likely always mention something as text generation, translation, summarization, question answering, and so forth. But it will be different in every instant. And that's the real important difference, which makes it so vastly interesting and fascinating, but also for some of us maybe scary, and for including myself, sometimes I'm like looking at this, I'm like, this can't be that good. Like, how is that possible? Like, I can copy and paste one of my emails into this and say, make it sound like Shakespeare, and it makes it sound like Shakespeare. I can say, make it sound like Samuel Beckett, and it makes it sound like rewrite my email as a Samuel Beckett play, and it'll try to do that. And that's fascinating because it has been trained, statistically trained, with all this knowledge of all Samuel Beckett plays, of all Shakespeare plays, and all that kind of stuff was on the web. It's been consumed by this model. And when I say trained, it means that the statistical properties of the language within those different text corpora will analyze, okay, the word famine always is followed by some kind of contextuation of blight or of potato and so forth. And these linguistic contextual differences and similarities are used in a statistical model, which we then call a large language model. So this entire thing is a statistical exercise, if we want to call it, and a statistical approach to identify how high the likelihood is that the next word is the best word in the context of the prompt or the question. I won't go too deep into how that works. I'm just going to mention it a little bit, but I'm happy to answer some of that in the Q&A, or come back to it, or point you to references or ways to learn this. And it's not that hard to learn, to be honest. It'll take you a few weeks to figure out, but you can start programming your own language models quite easy. If we look at the development of AI, it's pretty fascinating where we came from. If we think of the 40s, a man called Alan Turing Great movie with Cumberbatch in the main role. It's an amazing movie that just depicts kind of this life of Alan Turing, who was a mathematician and then a computer scientist, if you want to say. At that time, even my first professors in college, they were all mathematicians. So mathematics is the basic kind of approach to all of this, and it still is. I mean, it's pure statistics in most cases, and therefore maths plays a major role in all of this. Alan Turing came out with the first kind of thought processes around intelligent machines and around the so-called Turing test. How do we identify if a machine is equal of human intelligence or not? And he had this way of simplistically, or very kind of approachable kind of language and usage of these concepts, also down to very complicated concepts such as Turing machines, how to identify if a program terminates or not, which is very important, obviously, in the computer science sense. If a program doesn't terminate, then you get like a dead process, or you have to kind of open your task manager and kill the process or kill the program. So we need strong mathematical concepts and ethical concepts, and Alan Turing was one of the forefathers of that. And then we had these first AI systems and chatbots. Eliza was a very interesting one, but it was very much like a rule engine. So just in terms of the technologies again, a rule engine is an interface or computer or an expert system. We also called them expert systems around that time, where hardwired answers. If you think of Google a little bit like Google, just in a more specific case, where we have hardwired answers for specific cases. Rule engines were typically used in ATMs or cash machines, where you would put in your credit card, and then the rule engine would be, okay, PIN entered correctly or wrong. If correctly, then comes the next branch, and then this opens and so forth. So rule engines are still used, highly sophisticated, but very different than AI. Rule engines are very kind of static kind of beasts, but very fast, and once they're built, very effective and still have a good place. But then this AI revolution kind of continues. In 1997, we see Deep Blue beating Garry Kasparov in this famous chess match, and a lot of heuristics were used here. So Go was beaten then later down the line in 2015, which has a much higher complexity. But here we're talking of decision trees. So again, different. We're looking at decision trees where a chessboard or a Go game, so these kind of closed worlds of completely statistically analyzed, and all potential outcomes in this game tree, in this probabilistic tree, are analyzed with every single move. And to do that, certain heuristics are applied to kind of focus on specific outcomes of this larger decision tree. So really interesting stuff happens. And around 2017, we get this paper written by Google called Focuses on Transformers. So if you want to look at the history of this, thing, it's pretty fascinating how this first paper around transformers appears, and transformers being a concept which allows sentences. So we're now in the world of language. I haven't put anything around image or into. Ali's going to talk a little bit about that. So this is very much focused from this on forward. So from 2017 forward, very much focused on these transformer models in my part of the talk, which are very specific concepts that were introduced in this paper by Google engineers to analyze sentence structures ahead of time. So to really kind of, instead of just checking the next word, checking entire sentences and potentially entire context of a sentence, and taking these tokens, which are basically parts of words and sentences, and taking these tokens and processing a statistical model to understand what token comes after what token, so to get an understanding of how the language is used. So we've overcome what we always call the valley of AI, or the death of AI, or something like that, in the 80s. So you can see in the slides, between the 70s and the 80s, nothing happened. 70s and 80s, it's dead. But it kind of resurrected in the 90s, and definitely now you can see GPT-3 with 175 billion tokens and extending. And one of the main reasons that's often stated in why AI is now becoming so dominant and is such a transformative force in engineering and in computer science, and also now in business, is that we have a lot of data. We have, through the web and through the sinking costs of storage, we have an intense amount of data. And on top of this intense amount of data, we have extreme high levels of computer power. We have a lot of GPUs that we can use, and these GPUs becoming smaller and stronger. So we have computer power paired with a lot of data, on top of very much the same principles, statistical principles that came through the decades of science. Excuse me. So the main reasons for this revolution, often stated, is extreme computer power and extreme amounts of data to create the models in time. One other interesting part of this is that the adoption rate of technology has increased by tenfold almost. There is a benchmark typically for startups, especially platform-based startups, so platform economy, which is always cloud-based. We have 100 million user adoption for ChatGPT within 2 months, which is pretty insane. Which means you have 100 million. That's if you consider let's assume you have about 5 million on the island of Ireland, maybe 6 million. I don't know how much it is now exactly. So we have about 20 times of Ireland, if you want to take that number like that, of people signing up to ChatGPT and using ChatGPT on a daily basis within 2 months. So that's insane. That's a third of Europe or something like that. Pretty big numbers. So I'm just going to briefly go over a couple of parts. Just conscious of time now, and so if you think of the costs, one limitation is cost. So if you think of ChatGPT as an indexer of Google, it's really cheap. For Google, they have to index the web. Once they have the index, it's kind of very cheap to do this. They run big servers, obviously, but it's not compared with the cost that this stuff costs. So it's a daily cost of about 700,000. I'm sure it's close to 1 million now. But if you think the query cost, that's the part that I think is very interesting. That when you write a query into ChatGPT, it costs about 30 to 40 cents per query, because every query executes a new, fresh prompt into the language model for which GPUs are used. And the GPU costs are still pretty high, about $3 per hour for a very basic GPU. So each word that ChatGPT creates, when it says generate, each word that comes out of a large language model costs a fraction of about 3 cents. So you can kind of do the maths on this and how much money goes into this, and with Microsoft investing 10 billion, you can see where the money is going and where the money is needed. But at the same time, the commercial opportunities are huge. So the limitations are pretty much in 4 areas that I just want to kind of just briefly want to touch at: contextual understanding, generating misinformation, ethical concerns, and lack of creativity. And they're often mentioned throughout these kind of limitations. The contextual understanding, this is a statistical inference engine. It doesn't know what the bark is. It doesn't know that a tree in a poem is maybe something that relates to the history of humans, or is a romantic depiction, or a tree or a bark, anything like that, has a very deep meaning in the history of humans and in the context of humans and in the cultural context. So we humans, phenomenologistically speaking, we connect our environment and we connect these things with a deeper knowledge of our history, of our ancestors, with our archetypes and all these kind of things that travel through us and through the ages and are passed on throughout humanity. And in a statistical inference engine, we don't have that. So the contextual understanding, which is pretty vast in the human kind of context, is completely missing. And that creates big problems. If you copy and paste an email into ChatGPT, and if you have that email rephrased, you just type rephrase email, you will see that the rephrasing sometimes creates mismatched contextual understanding. So we're very far off general AI. We're very far off having a deep conversation with an AI, because it's basically just simulating what we know already. It's a pure simulation. And if you think the simulation is like a human, then you might be fooled. So it's just something that gets statistically generated. You could call it a Frankenstein if you want, with Halloween coming up pretty soon. But there's nothing that I can see on the horizon that will change that. There's ontological approaches, there's knowledge engineering. We have all these things, Wikipedia and knowledge graphs. They might help, but at the end of the day, a statistical inference engine doesn't have any history. It doesn't have any cultural contextual understanding, which brings us to the next part, which is the generation of misinformation. And generation of misinformation is really important, because I see it a lot with students. They use ChatGPT and then they don't check what is actually in ChatGPT. And because it uses the text of the web and it doesn't know what that means, you have a lot of mistakes. So for a while in ChatGPT, there was a mistake stating that Ireland only had 1 female president. And it didn't really understand. I had like factually wrong information inside. Ethical concerns, Ali is going to pick that up a little bit more. Ethical concerns are obviously around what impact does that have? Like if we have ChatGPT creating fake news, do we have it creating deliberately wrong context, deliberately wrong content? So how does that kind of work? And how are all these deep fake topics going to transpire, and how can we change them? And then I'm going to give a few backgrounds of how that is done. And then obviously this lack of creativity. And again, there's a big discussion about this with artists. And I did an experiment myself. I had a couple of years ago in the science gallery, I had a text generator, not this one, but the different one, generate poems. And I compared it with human poems. Not compared, I made a blind test. I asked the audience, is this done by a computer? Is this done by a human? And it was about 50-50, because poetry is always very cryptic. But obviously, once we read poetry, we really want to connect with the author of the poet, of the poet basically, and the context of the poet and the history of the poet. And then the poetry opens up a lot more, and that doesn't happen with LLMs or with this. So we get this very kind of shallow thing. And in image processing is very interesting. We suddenly get this kind of Picasso looking image, but if we go close, then it looks really kind of fabricated, and the clouds are kind of weirdly structured in the same way. It is creative, if we want to call that, but it's not novel in any way. So to overcome these limitations, pretty straightforward. We could use human evaluation, which ChatGPT uses a lot. This is kind of always forgotten on the dark side. And a lot of double and maybe triple million amounts of dollars went into human evaluation. So if you go into ChatGPT, it's very cleaned up. It's very sterile, if you want to say. There's no ranting. There's no bad language. It's very general. And that's because a lot of humans made sure that, for instance, all the data that was pulled from Reddit, and ChatGPT was trained a lot on Reddit data. One of the reasons why Reddit had to kind of shut down the API and make it commercial is because it was hit by all these AI bots to mine the Reddit discussions. A lot of the ranting in Reddit was taken out by humans. A lot of the harmful content was taken out by humans. So we have a vast amount of human filtering in there, thinking this is a machine that's doing magic, but it's actually a ton of humans that are paid maybe $12 an hour or less to somehow comb through this. We have the same problem with social media. Social media is heavily filtered and evaluated by human annotators. And we have no technology that can change that, because we humans are just luckily too different and too smart to kind of not be detected by machines or algorithms. Automated metrics. So there's a lot of that work happening at the moment, how to create specific metrics that allow the evaluation of performances and scalability. I haven't really mentioned a lot of them here, but I can go into those in the Q&A if you want. Adversarial testing is very important, and that kind of brings a lot of kind of AI approaches into the fold, and also bias evaluation and distribution testing. So is the data biased? And there's a lot of negative examples where AI models were used in the jurisdictions in the system, in the law systems, where suddenly it was racially biased because the data was from the 70s. So we get a lot of those things. Just want to talk about tokens. Token limits are pretty big as well. Like if you think of ChatGPT using a couple of billion tokens, so language models work on tokens. 32,000 tokens is typically 50 pages of content, and these tokens are pretty limiting, because the GPU behind it has to work on the token level, and there's a certain limit on tokens. We're now in the billions of tokens, and it takes about 3 months to train a language model on that number. But you can kind of figure out how quick the amount of text is a problem. But text is a problem, so we're running out of text. The web is basically mined. All the novels are mined. So the question is, on the limitation, how can large language models get better if the web is basically already mined? So we have a token limitation, a very stark token limitation, but we also have a limitation of the actual amount of text possibly to be explored anyway. So now Google is kind of looking into using all our emails in Gmail, if we allow that with their system and so forth. There is a thing called explainable AI. This hasn't been really a breakthrough yet. So once the model is trained and creates a statistical outcome, it's very hard to understand where this outcome is coming from. There are approaches in the works to understand that, which is the term here used as explainable AI. Controlling the output again is with human feedback. You give the system feedback saying this is a good output, this is a bad output, and the reinforcement loop allows the AI to learn. And if we look at the different case studies. So Google has a system called BERT, very similar to ChatGPT, but also now installed, you can enable it to read your emails and make you talk. And if there's enough emails, it will talk your language basically and write emails for you. So these are interesting developments. And also Word integrating ChatGPT, Microsoft integrating ChatGPT into the Word platform. And those are interesting overlaps. IBM has a debater platform, which was used for game shows, which you might have seen in the kind of popular press. Using also natural language. And I just finished with the environmental limitations. ChatGPT 3.5 basically as about 175 billion tokens. And in terms of consumption, we can kind of look at the amount of GPUs that were used. About 25,000 GPUs were used over 3 months. So a 3-month-long training process with a lot of GPUs. With a lot of costs, that model cost about $100 million. So just giving you the idea of costs. And the usage in metric tons in CO2 was about 550,000 tons. And that's as if you have 2 or 3 full Boeing 747s flying round trips from New York to San Francisco. So that kind of gives you an idea how much energy consumption is needed to do this. So if we would be doing this in real time with real data, with real emails and real chat, and not just with historical data, obviously it would be like flying planes all over the planet all the time. And the energy consumption, I was told of now, large language model trainings that are happening at the moment worldwide are about the energy consumption of the country of the Netherlands. So that's basically it in a whirlwind, basically in the short time I had. So I have a couple of, you're going to get all these slides so you can kind of look at this yourself. And I mentioned a few technologies, but I'm happy to go into any of these aspects a little bit deeper. The good news is that the limitations are so high that you don't have to be worried about losing your sanity anytime soon. The bad news is obviously we want to see these technologies help us, and there's still a lot of work to do. Thank you.
Thank you so much, Kevin. Quite a hard task to summarize such a big topic in 25 minutes. So fair play. And as you mentioned, we can share the slides and obviously this recording with anyone who's attending. I'm really happy to see there's already some questions flying in the Q&A. So yeah, we will get to them. But for now, I'm going to hand over to Ali.
Excellent. Thank you everyone for coming in today. I hope everyone can see the slides. Let me know if you can't. So my name is Ali. I'm coming from a mechanical engineering background, but transitioned into software engineering after I became chartered, and basically been working in this field for a while now. When I was working for my previous employer, I worked mostly on quite a lot of basically rail detection and edge detection in AI, mostly within rail. So this includes building computer vision tools to help manage vegetation, manage pantographs, if there are any kind of like debris on them, as well as building regression models to identify and predict delays within rail networks. And then part of that also included building computer vision models to help count people on and off count passengers basically on and off the buses and trains. So these kind of models basically are all some of the latest advancements in AI, and that has been recently happening. And I've been lucky enough to be working on these kind of like technologies. Before then, I then transitioned into working for a data science consultancy as the head of engineering, and running workshops and running webinars in relation to showing how engineers can start utilizing AI within their own fields, and understanding like how this technology could be used, similar to like how we use our day-to-day tools like MATLAB or ANSYS or CATIA or SolidWorks. So it's just literally just another tool in the box that allows us to build solutions for like specific different engineering problems that we have today. So what I wanted to do with this webinar is mostly to go over some of the overview concepts to understand what the AI landscape looks like and how it has improved and grown over the past few years. Just get a bit of intuitive understanding of how AI works and appreciate why it's actually hard to implement ethics within AI compared to other fields. And also learn a bit more about the inner workings of some of the cutting edge models such as ChatGPT, Stable Diffusion models, Gato, like these kind of like really, really novel models that has come around that like are actually surpassing like human capabilities. And also just to help you visualize a bit of like what AI can do within your own respective fields. So just to show you like how the landscape has like grown over the past few years, like AI in 2012, the data, AI, and machine learning landscape was just a couple of few companies. Like you could actually like put them on one single slide and you can actually see like logos of each company. Now the landscape has grown so fast and so big that you can see how it's gone from 2012 to 2023 in just literally in like 10 years. So it makes it really difficult to keep up with it, but at the same time, it also makes it difficult to understand what tools we need to adopt, what technologies we need to learn. And that's why it's really hard to understand AI, just because of like how fast it's moving. And it's only with the recent advent and like coming of ChatGPT that like people and companies are not really taking it seriously, because it was there before. Like GPT-3 was released years ago, but it was until GPT 3.5 that got released with a user interface on top that like people then started seeing like how AI can be used properly. So another thing to notice as well, especially like in the UK, there has been a study that has done in the AI adoption rates within the UK economy, and pretty much in all scenarios, whether it's for small companies, medium companies, large companies, there's going to be a massive demand as we go towards 2040 in like basically demand for AI labor, like people who know AI and like know how to build AI systems, as well as AI technology. So companies are actually putting in budgets and money towards hiring people with AI skills, especially like engineers, as well as trying to adopt this technology, because it's just like computer. It's like the advent of computer. Before, people used to have like paper spreadsheets, and then computers came, Excel came, and then like we now do everything in Excel. It's the same thing. Like it helps us automate some of the repetitive tasks that normally the humans used to like sit down and like put music in their ear to do. Now you actually just can delegate this to like a technology in your computer to run it for you. And like the way I'm seeing it is that in the future, well, in the coming years, basically engineers will also be data scientists. So what I mean by that is we all engineers, we have the mathematics and science and statistics background from like our university education. And we also have learned to use a variety of different tools. Maybe some of us even learned some programming in MATLAB or in Python. So with those, you can like start doing machine learning to some extent, like work with machine learning technologies. But one thing that separates engineers apart from rest of the population is the fact that engineers also know and have domain/business knowledge. And when you combine all of this together, is like gives you an edge compared to the rest of the population, just because not everyone has that red circle within this Venn diagram. And it takes years of practice and study, which engineers normally have to go through to get to that stage. But AI is just basically just another tech in the tech stack. And I think engineers who don't start improving on their blue skills in this picture might be left behind. That's why it's important to start learning how this technology works and how can you adopt it within your current and existing workflows. just like similar to how mechanical engineers had to learn SolidWorks so that they could design 3D components and use parametric modeling and computational fluid dynamics simulation softwares to like understand forces within their like components. It's the same thing. It's just another tool in the toolbox. Doesn't necessarily mean it has any kind of negative impact in your careers, but it will have an impact. It will change things. And it's important to know that like in the future, it might be expected of engineers to know how to use this tool, even if they are not actually writing programs, they are just using no-code tools for it. So there are actually no-code tools around that allow you to build AI models. And one of them is called Azure Machine Learning Studio. And like these tools allow you to use drag and drop and like attach your data set to it and build models on top. And you can use these to build several applications as you go forward. So this brings us to the fact that it's quite hard to keep up pace with AI, just because a lot of companies are really like pushing forward to implement new AI technologies within their and adopt it. And the reason it makes it hard ethically, like especially around the ethical consideration, is the fact that, first of all, one of the biggest ones is there is always some kind of bias in the data that reduce, and also quality issues with the data. So if this bias exists in the data, it also comes within the model. And it can be introduced inside these models. The fact that the systems are complex and there are some emergent properties that could come up based on the interactions of these models with the various other systems. These companies may choose incorrect evaluation methods and wrong metrics when it comes to like assessing their models. They might have unintended consequences. So you never know how someone may use some of these models that you put. Then you have some kind of trade-off between how fast the technology is moving and how fast you want to race to the market and start using that technology. Because if the technology is quite new and you race to the market to actually like use that technology, it may not be ready yet and it may have some issues. Whilst at the same time, if you don't get to the market fast enough, a new technology might come in, a new AI technology might come in, and at the same time, all of that effort that you put in building a prototype goes down the drain because something new came. For example, ChatGPT, when it came, all the other older technologies such as long short-term memory networks, they are now obsolete. Like how much money those companies spent on building those kind of like natural language processing technologies, they are now obsolete because the transformer algorithm and the way you build transformers have completely revolutionized how you process textual data. Other things that is actually quite a challenge in AI is the fact that there aren't quite a lot of standards, regulation, processes. I think European Union have set in place some standards, but still it's not very clear what the accountabilities, responsibilities of people and projects are who are building these systems. And also different cultures have different expectations of like how these systems should perform. And also it's a bit of hard to interpret what these models are doing. So you can't like easily open them up. They're kind of like black boxes because of how complex they are, and people could abuse and misuse them. So because of like these issues, it makes it difficult to like, at the same time we're building and prototyping these models, adhere to some of these ethical issues. And like there is ongoing work in this area still to keep up with the technological advancement that's happening within the AI field. So before I go forward into some of the technical details, I wanted to just clear some of the confusion around AI, machine learning, and deep learning. So these are like words that keeps getting thrown around a lot. You will hear them quite a lot in the AI circle. But basically what I want you to think about is this coinciding circles diagram. AI basically refers to any kind of machine that can mimic human behavior. So like encompasses everything, including machine learning and deep learning. Whereas machine learning is more like statistical algorithms that build statistical models on top like of your data. So you basically use statistical algorithms to do that. And one of those statistical algorithms is the ones that use neural networks. So the ones that use neural networks is called deep learning. And most of the fascinating results that we've seen so far normally happens in deep learning. In machine learning, you have like support vector machines, you have like regression models, classification models, so like traditional machine learning techniques that you may have seen, but it's only these deep learning techniques that are actually quite really fascinating and may surpass human like outputs to some extent. And the whole field of artificial intelligence could be also it's big enough that encompasses these, but also like focuses on other areas as well, like pathfinding, like areas that don't necessarily fall within machine learning and deep learning itself. So AI and overall is like a very big, massive field. And a subset of that is machine learning, and a subset of that is deep learning. And deep learning is where we're going to be really interested in and talk about today, just because all of the recent advancements normally happens in this area where neural networks are in play. And when we talk about neurons, basically what we have done, or what have researchers have done in the past few years, is they have taken basically how your brain works. It's just a collection of neurons. So these neuron cells send signals throughout your brain, and each neuron is connected to a bunch of other neurons, and they are receiving a set of signals, either positive or negative. If the positive signals are big enough, then your neuron of focus will send a signal to the next one. Otherwise, it will not send a signal, and your neuron is kind of like blocking the other neurons from sending the signal. This whole like behavior, what researchers have done is they have managed to figure out the mathematics, or like a simple mathematical representation for it, in a way so that they can like send the data through a network and use these mathematical equations to figure out how the data is being mapped from inputs to outputs. So how the data could be processed from inputs to outputs to perform a prediction. So similar to how your brain works. So your brain takes some inputs, learns the patterns in it, and then it can then perform some kind of action. For example, when you're learning how to play piano, you are figuring out how to place your hands on the piano keyboards and like how to play the keywords itself, especially with both hands at the same time. And all of these are like basically neural pathways in your brain that are becoming more activated and wired together and fire together in order for you to learn the skill. This behavior is something that you can use mathematics to actually model, and that's basically what AI researchers have done. They have used these mathematical notations and linear algebra to implement this mathematics going forward. And basically what you could do is you could end up connecting these neurons together and create a neural network. And when you pass a data, such as an image from the left-hand side of the network through the neural network to the right-hand side, the left-hand side basically takes the image as an input. It's just basically a bunch of pixels under the hood. And then as the image goes through the network learns basically patterns within this image, like vertical edges, horizontal edges, and then these edges combine into shapes, and then the shapes combine into like patterns within objects, and then these patterns in the objects combine into an actual like understanding of like what the picture is. So that's how the network learns as you go from left to right. It learns more higher level patterns in the image or in the data. It couldn't be image, it could be anything. And then this is how it can, for example, predict if it's looking at the face of a George Washington or face of myself or face of someone else. In this specific example where like it's trying to predict whose face this image is showing. But like neural networks, the same concept can be applied to basically make predictions on anything, not just face detection. And basically, when we talk about images, they are just stored in a computer as an array of numbers. So you can see like how in this number 8 can be shown as an array of numbers. So what this allows us to do is basically it allows us to perform any kind of image problem into a mathematical problem. So you can basically pass images through these networks and do any kind of task on them. Like you can classify the image, you can identify where the object is in the image and classify it. You can basically identify all the objects within the image and draw bounding boxes around them and like follow them in the image in like a video. You can basically classify every pixel in the image and like identify exactly like the borders of every object, and we call that instance segmentation. So you can do any kind of sort of like tasks within this in order to implement what you're trying to achieve. Like, for example, in here, this is a convolutional neural network, a specific type of network that's really used normally for images. And you can see as the image is going from left to right, every layer of the network, you can see what the network is seeing. It's just using a bunch of filters, like Instagram filters, to identify the edges and the patterns in the image. And then as these patterns go through the network learns more about the shapes and the patterns it sees. And then they can then use those at the final layers to identify what it is looking at exactly when it comes to like a classification task as it is seen here. So this network is trying to classify what image it's seeing from the input image, whether it's a car, it's a ship, it's an airplane, and so on. You can imagine that this doesn't necessarily need to just do cat, dog, or car. You can actually train it to do any kind of like use case within engineering, for example, whether it's looking at a faulty component or is it not looking at a faulty component? Is it looking at a crack or is it not crack? If it's a crack, like what kind of crack is it looking at? What kind of like fault is it? Like you can even use it as fault classification if you're using imagery data. One example of a company that has done this really well is a company in it's a company based in Israel, and this is an Israeli company that has managed to use computer vision and like depth cameras to identify tracks, to perform pathfinding, calculate distance to trains, identify like whether there are track workers on the trains, and like the distance to those track workers. So like this is like how you can see how computer vision could be applied in this such scenarios. It's like really, really fascinating. So one of these models, like cutting edge models that they use, is called You Look Only Once, or YOLO. And basically what this does is that they in the YOLO model, you basically divide an image into a grid, and then you try to predict within each grid if you're looking at an object, and then identifying the rectangle or the bounding box corners of this object. And you end up detecting a lot of bounding boxes, and then you have to use a method called non-maximal suppression to remove all the noise bounding boxes. And then at the end, you can use a metric such as IOU, area of overlap over area of union, to identify whether your prediction of where the bounding box prediction of where your object is, does it exactly overlap the bounding box of where the object should be. And this is like a metric you can use to see if your model is performing well or not okay. And you can like classify every bounding box into like a dog, a bicycle, a car, and like this is how you can actually detect objects within images. And then basically videos are just basically a collection of images. A sequences of images becomes a video, so you can actually use it to like detect and track objects in a video. And this could be quite useful in like various scenarios, like you saw with that rail company that have implemented it. Another one that is interesting is basically in generative AI, stable diffusion. So these are basically models that have learned patterns in images, and they have mapped this pattern in a mathematical space called the latent space. And then in this latent space, everything is like basically a noise. And then what you do is whenever you want to generate an image, you start with a noisy image, and then your model has learned to denoise it. And then you basically perform a iteration of steps to denoise your noisy image one step at a time until you reach back to the original image. So whatever image you want to create, you basically pick a space from within this noise latent space, and then you then bring it back to the real world space where an actual image could be generated. So this is called the denoising stable diffusion model, and it's quite an interesting way of how like generative models are actually performing and learning. Another cutting edge model is called Gato, and this one is quite fascinating. This is basically, instead of having a single model specialized on a single task, there is a new model that DeepMind has come up with, and this one is basically could be like sparks of general artificial intelligence, and it uses reinforcement learning, which is basically like how kids learn by trial and error. And you basically, this is a model that can perform like up to 700 tasks, such as it can talk to you like ChatGPT. It can move a robot hand to move blocks. It can answer questions. It can play Atari games. It can play chess with you, like everything. It has learned basically 700 different skills, and all of it is in one model. So instead of like having multiple models, they have like it'll specialize. It has learned everything in one model. And the way it's done that is basically it takes data and concatenates all the data together and learn from it across a variety of different environments. And it's actually quite interesting how you can actually use this in like other areas where you don't have to manage multiple model assets in order to like go forward with what you're trying to achieve. I think Kevin touched upon large language models as well, but basically in ChatGPT scenario, it wasn't actually trained once, it was trained 3 times in order to achieve the state-of-the-art state where it is right now. So first, they trained it on some text data from Reddit and a bunch of other areas. Then they had to basically put this model in front of humans. Humans then ranked the model based on its responses to questions. And then because it was quite a lot of basically assessment work to do on this model to teach it, what they ended up doing is they ended up building another model called the reward model that was learned how to assess the outputs of ChatGPT. And then they had another training session where an AI model was rewarding ChatGPT on its performance, and ChatGPT had to learn how to produce outputs in a way that it can basically get the highest rewards from the reward model. So it's basically an AI model training another AI model until ChatGPT got to the state where it is right now. So that's why how it's fascinating how some of these technologies are coming into play. And basically, as Kevin said, ChatGPT was basically trained to predict the next word in a sentence. So if a sentence is a sequence of tokens, is each token just a word? What ChatGPT has done is that it has learned the meaning of each word in the vocabulary and the meaning of a word inside a sentence in the context of other words within the sentence. And what it's trying to do is in each sequence of words, it's trying to predict the next best possible word that match the next word in the sentence that it needs to predict. And it's just basically a word predictor. It's a glorified word predictor. And it's trying to predict what word comes next in the sentence. I think the best way to understand it is this example. So when you say the elephant could not fit into the car because it was too underline, we know that like big should be the word that comes here, because we look at the elephant and we look at trying to fit an elephant into a car. So we say, okay, because the elephant was too big, it couldn't fit into the car. But another sentence, if we say the elephant could not run after the car because it was too ... we know we should say slow here, not big, because the context here is basically the speed or running after a car. So this mechanism that ChatGPT has, or transformer models have, is called an attention head. They have an attention head block layer in the neural network. And what it does is that it knows how to focus on certain keywords within the sentence in relation to each other in order to understand the context and the meaning. And the way it has learned the meaning is that in an English vocabulary, it has used mathematics to identify which words have similar meanings together. For example, coffee, tea, lemonade, they are words that cluster together in this mathematical space. Sheep, car, bike, they cluster together in a mathematical space. And fish, salad, stew, they all kind of like cluster together in a mathematical space. And with the context of what the sentence is, it can then try to predict the best word from this mathematical space in a way that like completes the sentence. So this was basically what I had to show you within the current time frame of what we had in this webinar, but I hope it was useful for you. And then, yeah, like if you have any questions about these latest technologies and advancements, yeah, please feel free to post them in the chat and we will try to answer them. Thank you.
Thank you so much, Ali, and Kevin. So yeah, as I thought, with a topic like this, an hour is just not long enough. Kevin, I saw that you were working away at the Q&A as Ali was speaking. There's just one question left there. It's just a question about what are your thoughts on the possibility of a future over-dependent on AI. We might just hold off on answering that just with the time frame that we have, but I do think it's worthwhile mentioning if what was spoken about today is of interest to you, and you are looking to educate yourself further in AI. I just want to draw your attention to a new course that we will be running here in Engineers Ireland, which Ali will be our facilitator for. So the course is on the 29th of November. It's online. It starts at 9:30, finishing at 4:30. It is the fundamentals of AI for engineers. You can register online if you go onto our website. It's under the CPD calendar. So just a rough overview of what the course will provide. So it's aimed to guide engineers through the AI realm, addressing ethical concerns, planning AI initiatives, and identifying AI's role in their processes. Tailored for those new to AI, the course provides a comprehensive perspective on AI, ensuring attendees develop a natural understanding of its working. So it's the first of its kind in terms of the course that's being offered. So definitely get registered if that's something of interest to you. We also have two seminars that I'm just going, or a seminar and a conference to draw your attention to. We have our Wastewaters Network seminar on the 9th of November, and then the Meta Asset Management Conference, which is on the 23rd of November. So look, as I said, we will be providing the recording to this webinar, but if there are any questions or anything, any feedback that you wanted to provide, I will be emailing out the recording, so you'll have my email there. Feel free to respond. I can direct any questions or queries to Kevin or Ali, and I think this is definitely a topic that we want to build on in the future. So look, just want to thank Ali and Kevin very much for your time and your expertise on the topic, and thank you everyone who was in attendance. Thank you. Have a lovely day.
Thank you. Bye-bye.
Thank you. Bye-bye.